Good afternoon, good evening, everybody. My name is Simon Steele, and welcome to episode 3 of the Effects of Gravity. I am an astronomer and also Director of Education and Public Outreach at the SETI Institute, located in Mountain View, California. SETI stands for the Search for Extraterrestrial Intelligence, and the Institute, which has over 100 research scientists, is the only institute in the world dedicated to searching for life in the universe in all its forms, everything from microbes on Mars to extraterrestrial advanced civilizations. We're very happy to be involved in this project for this special episode 3. We have our own collaboration between art and science. It's called the AIR program, the Artist in Residence program. And it's the synthesis between science, art, and imagination that I think is so important to communicate and comprehend some of these incredibly advanced and complex ideas of the evolution of the universe and the existence of life in that universe. Without further ado, I am going to invite you all to put your comments and questions onto YouTube as you watch these videos and hear from the Effects of Gravity team. I'm also going to invite you to put on a nice pair of headphones because the sound is fabulous with headphones. There's some really good music and it will make everything sound so much clearer. So pop on those very nice headphones. We're going to watch, first of all, an introductory video to give you some background of the project Effects of Gravity, and then we'll meet the Effects of Gravity team.
The Milky Way galaxy, our solar system, our planet Earth, and life itself have their origins in and are sustained by the effects of gravity. In this image, we look deep into the night sky beyond the Milky Way to other galaxies. The red objects are some of the most distant in our universe. We see them as they were 1 billion years after the Big Bang launched the expansion of the universe. It was not big or a bang, though. Our universe started vanishingly small and intensely luminous. Let's call that moment what it really was, the small flash. The moving images we are about to experience are computer simulations based on astrophysical data, direct observations of our cosmic origins. The simulations represent how the galaxies formed. When models like these match what we actually observe in the universe, we call them accurate. They have predictive power. As they fall into one another, the galaxies pull, warp, and distort. Soon, they will appear to fragment and then become one. Because of the vast distances between individual stars, none will collide.
In 4 billion years, home galaxy will collide with Andromeda. But the apparent catastrophe won't trouble even a single blade of grass, won't dither whatever bio-cyber consciousness survives the cycle of infinite extinctions. They will approach. They will interact with spectacular gravitational dynamics, two becoming one. The way that true lovers caress changed everything forever.
Earth is here. We are here as a direct result of hydrogen atoms left to do what atoms do under the influence of gravity over vast stretches of time. The scientific and aesthetic appreciation of what it took to form us, our Earth, our solar system, our galaxy, and over 2 trillion other galaxies, enables a grasp of our cosmic origins, reminding us that we are small and also vast and powerful effects of gravity.
So that was beautiful. Let's meet the effects of gravity team. We'll start with Luke Keller. Luke Keller is a professor of physics and astronomy at Ithaca College in Ithaca, New York. His astrophysics research focuses on the formation of stars and the planetary systems. Much of his teaching focuses on the nature of science and its role in our understanding of the universe. Hi, Luke.
Hi, Simon.
Next is David Gonzalez. David is a nationally touring poet, musician, and storyteller, fellow of the Joseph Campbell Foundation. He's received numerous commissions and awards. His doctoral dissertation studied the intersection of improvised music and mythology with a psychotherapeutic context. So, hi, David.
Hey there, Simon. Thank you.
Hi. And finally, Alvaro Domene is a Madrid-born, New York-based guitarist and composer operating at the convergence of various styles of contemporary music. His sound and compositions are influenced by the jazz and Western contemporary classical traditions, as well as metal music. That's my favorite. Alvaro co-runs Illuso Records, an independent record label dedicated to supporting and distributing creative new music. He's also the artistic director at the Singularity Music Series in Kingston, New York. Hi there, Alvaro.
Hello, how's it going,
Hi.
Simon?
Good, good. Nice to see everybody. So we're going to have a few questions and like to hear more about this project from you all. We're going to start with David. David, can you talk a little bit about the origin of the Effects of Gravity project?
Well, I think all of us have our own origin story. For me, it started when I was a Boy Scout looking up at the stars. That's where it starts, you know, that sense of wonder. Through my life as a writer and as a musician, I've always been inspired by the cosmos. And so a lot of poetry that I've written. And when I met Luke at a conference, we had a couple of great conversations. We started knocking ideas around, and then met Alvaro, who shared this interest and passion. And then over drinks and coffees, we started, you know, playing with these ideas, not only from our mutual interest, but our own, I'd say, collective desire to want to communicate and explore how this confluence of arts and sciences could be effective in the world.
Yeah. Okay. Alvaro, there's a creative process here and some very sort of abstract imagery going on. Tell us a little bit about the creative process that goes on in your mind for the sounds that you create for this project.
Sure. I usually start by watching the video on which we're working. Also read the poetry and, of course, the scientific explanation of the concept behind it all. And by doing this, my sonic imagination gets triggered immediately in different ways. So, for instance, sometimes the videos offer some factors that seem adaptable to be replicated musically in a certain fashion. Like on this one, gas movements and the rate at which they morph can be used as rhythmic and tempo cues. So I might keep that in mind for the speed at which certain melodies are played or maybe looped and processed. So I try not to be blatantly obvious about the imitation from the visual to the sonic, but definitely taking into consideration for the cohesiveness of the piece.
Okay, yeah. And Luke, I'm an astronomer, so I'm sort of coming this from your direction. And of course, most of the times when you're talking about these concepts is to scientists, and yet now this work is being interpreted by poets, by musicians. How does that affect your narrative in these pieces of science?
Well, my inspiration for the narrative is really came from the images themselves, which I see as astrophysical models, and I wanted to see if we could explain them through poetry and through my narrative in a way that is accessible to anyone who's interested, and yet doesn't pull any punches in terms of the astrophysics. So I tried to be as brief as possible, but also as comprehensive and accurate as possible.
Okay. So brevity is not necessarily the role of the poet, although it can be. David, what's the role of poetry here? Tell us, what does this do?
You know, it's lived experience. Putting words onto the unknown, to the mystery, is what poetry does, trying to sort of bridge the gap between felt sense, imagination, and information. It's an avenue of meaning making. And if anything is ever going to blow a fuse, like, I don't know how you guys astronomers go to work every day, because like the fuses just go pop, pop. How do you, comprehend?
We go to work every night, not every day. Of course.
I'm sorry.
Yes,
Maybe that helps.
Yeah.
But for me, writing poetry and the role of, I think, poetry in the project is to start giving vocabulary that begins to bridge a lived human experience with these largely unfathomable distances and phenomenon, and to make it on a human scale, so that we can bring our understanding into it in a way that's perhaps more palatable, more palpable, or maybe both.
Mm-hmm. Because we are bridging the gap between the size of humanity, the size of our experience, and the biggest structures in the universe. That's effectively impossible to comprehend, and yet the idea of poetry, music is allowing you maybe to grasp some of these concepts and try and get a feel for them. And Alvaro, you're interpreting this in a musical sense. How do you choose the instruments? What are you playing here that you can draw this vastness to a human level?
All the sounds in this project are generated with a guitar.
Okay.
Specifically a 7-string electric guitar. Mm-hmm. And this particular guitar is made by a Swedish company named Strandberg, and they make great ergonomic and very good sounding instruments. But in order to extend the capabilities and tonal palette of the guitar, I do use external processing devices that help me manipulate my sound in multiple ways. So depending on what the pieces requires, I might use sounds that are familiar in my arsenal, or I might sculpt new ones by programming these devices, guitar pedals and things like that. Or I use them in unconventional or wrong ways.
So what does this particular
all guitar stuff?
It's all guitar. But why this particular brand? Why not just pull a Fender Stratocaster off the wall? I mean, what's this guitar doing for you?
Well, I wish I had it right here. It's if you want to get geeky about it, the fact that it's a 7-string multi-scale guitar, that means that the length of the fretboard is not the same throughout all the strings. So the strings on the low register, the low E, and in my case, the low A, the 7th string, are on a longer scale. So what that facilitates is better intonation when playing with such low tuning. And that helps cutting through mixes, being more comfortable to play. And in general, the whole instrument gains more clarity when the range of the string matches the tuning of the string. Mm-hmm. And that's one of the main factors for this particular instrument. I can go really low and still keep the clarity.
Interesting. Yeah, the sound range is something, we're dealing with size and scale range, and the sound range is you want to bring out this immensity, and that's wonderful. Luke, just talk a little bit about the physical details of the narrative in terms of the science that you're trying to get across.
Well, because I'm trying to be as brief as possible, to leave room for the musical and poetic experience, I try to explain what the audience is seeing and also how it relates to us. So it's definitely telling the story of origins. That's in the back of my mind all the time, that the facts that I'm relating are details in this larger story of origins.
Mm-hmm, mm-hmm. Well, I think it's time to take a look at this video. And so I would like to introduce episode 3 of Effects of Gravity. And this is entitled Galaxy Formation.
My universe started with a big bang at a Niagara Falls motel. A kiss, a caress, a gasp. The insistent, flippy swim of a sperm to an egg. Twinning mitosis, tadpole, amphibian, fetus in mother's. Birth, breath, breast, creatureliness, instincts. Clan, culture, companions, creations. Questions into the mystery. The universe started with a small flash atop a stack of infinite turtles, all hydrogen, helium, but for the 2% we are. Undone beds, pots and pans in the sink, magicians, and heretics. Gravity and attraction, galaxy formation, stellar furnaces burning, proton by proton churning out the periodic table, and the billion incidental planets with their peculiarities, their distance to their home star, their orbital dynamics, atmospheric conditions, and elemental composition, and all the particles in their particular manifestations. The universe and my universe are entwined as a double helix. Take one away and the other ceases to function. The universe has made the mind. The mind has made the universe. Space-time flows through solar storms and the bones of this body. The atoms in these fingers and the pixel-scribed words they set on the page are saturated with radiation from the instant of cosmic beginning. These very words, spoken aloud in this warm room, echo into infinity. Let every poet study the stars. Let every astronomer be a lyricist. Let's start again. Let's return to the gnarly questions, to the straight facts, to the fractal flux, where my universe and the universe are one. Somewhere in this, may revelation begin.
Starting less than 1 billion years after the beginning of the observable universe, a massive cloud of gas and dark matter streams inward. A galaxy forms in the core of this region of growing matter density, where the effects of gravity are strong. Shades of orange and purple in the main view show us the gas, in the beginning mostly hydrogen, attracted to a central core of dark matter. Shades of orange and white in the lower left inset show us the wispy tendrils and dense masses of dark matter surrounding the forming galaxy. Two insets at lower right show us starlight in the galaxy, shades of white and pale yellow in the left box, and gas density in the galaxy, shades of yellow and purple in the right box. Pausing the simulation for a moment, shades of blue and green now show us the density of gas composed of atoms heavier than hydrogen and helium. Then shades of orange show us how fast the gas is moving. Lighter color shows gas that is moving faster. Now we see the glowing gas in the central disk of the new galaxy, and then transition back to our original view of the surrounding gas. Stars form at an increasing rate within the forming galaxy as gas there condenses. We observe a resulting increase in the brightness and size of the galaxy as seen in the light of its stars. The simulation ends after about 13 billion years with an effect of gravity known as a spiral galaxy. Our Sun is one of many stars in a spiral galaxy. We call it the Milky Way. This simulation is a working astrophysical model based on a scientific theory of galaxy formation. The model is informed by decades of observations characterizing distant galaxies and light from the early universe before galaxies existed. If the model is accurate, the theory it is based on is also accurate, and the resulting simulated galaxy will closely resemble actual galaxies that we observe in the present time. Here's the model galaxy from the simulation. And here's an actual galaxy.
Okay, quite amazing. Visually, audially, that was beautiful. And of course, what we're seeing there is not only the birth of the galaxy or a galaxy. We're seeing the birth of us. This is the creation of complexity in a way. And in order to have life, you need galaxies. You need the galaxies to become complex. And then once you have galaxies, you can have planets. You can have life. And then from that, you get intelligence. And so we are seeing in these models, going back to David's concept of conception, in a way, and we'll talk more about that when I ask you a little bit later on. That we're this is the birth of universal intelligence in a way, manifest in humans. So it really is fundamentally important and part of our being, what this is demonstrating. Okay, we're going to start just with a question for Alvaro. Now that we've seen the video, the galaxy formation, could you bring up a couple of examples of how this imagery inspires your compositions? Talk us a little bit through that.
Yeah, sure. For instance, Luke's first, I think it's the first sentence on the video, mentions, talks about a massive cloud of gas and also dark matter that streams inward. So when I read that, I started thinking of, okay, how can what does that mean to me musically or sonically, right? So I can evoke that type of imagery by playing a group of pitches, of notes or textures that can be looped and transformed throughout every rotation of them, right? So to kind of mimic just the imagery of it. Another example, I might also assign a specific harmony or a sonic motif to the colors that show up in different shades, orange and purple, white, because the brighter the color, the more auspicious the harmony, and vice versa. So if we go to darker colors, they can evoke gloom and even fear. So I think there's a very inspiring juxtaposition in these video models. In this sense, to me, they always transmit a sense of peace and stability, and at the same time, extreme forces of turbulence and discordance. So I try to synthesize all that,
Yeah. So bringing sort of human emotion into this purely physical gravitational process. That's really cool. Luca, there are two types of astronomers in the world. It sounds like the start of a joke, but there's a theorist, the model builder, and then there's the observer, and this is the synthesis in a way of what's coming out of that. Can you say a little bit more about theory and observation and their roles here?
Yeah, so the scientific process or the scientific method is our best way, the best way we know to build a physical understanding, a story of the universe. And as you say, there are observations. We look with our eyes, with telescopes, with other tools, and then we try to synthesize an explanation of as much detail as possible. And that's the theory. And I think a complete understanding involves both, and not just the facts, but how we know those. So the process itself. So I try to emphasize the process of science in this project as just kind of an underlying theme, because I think it's also an inspiring story. How we know all of this is as inspiring as what we've learned.
Yeah, I agree. David, your poem here, it maybe has come as a little bit of a shock to people out of an astrophysical modeling simulation, because you bring in human intimacy and biology to this. And I mentioned a little bit before that what we're seeing is indeed a birth of humanity modeled, but you're bringing this almost to the next level of connectivity here and talking about human intimacy. Can you say a little bit more about human intimacy and galaxy formation, and from your perspective?
Well, you know the old adage, write what you know.
Yeah.
So I love what you said, that we think about Mother Earth, and of course, yes, Mother Earth. This is the ground from which we spring, all of us, back to time immemorial. Yet you have to ask the question, from where does Mother Earth spring? And then we look at planetary formation, and then we look at galactical formation, and then we look at all the massive structures of the cosmos. And so I was once at a conference, and people were talking about their origin stories, and there were all these different variations on that. Some were cultural, some were racial, some were ethnic, and I trace my own origin story back to these cosmological phenomenon, and that therein is the mystery, and therein is the beauty. And I think that identifying with the generative sources of the universe, for me personally, is liberating. And I actually think that once we can open up our own sense of belonging beyond our clan, beyond our tribe, beyond our country, beyond the world, even, it opens up possibilities, let's just say. And so I've written that poem with it's kind of sexy, it's about mother and father getting it on, and boom, there it is, the flippy swim, the insistent flippy swim of the sperm to an egg. These are forces and dynamics which are undeniable. We live by them. We die by them. We celebrate by them. We are in anguish by them. These primal forces. And, I see, looking at these videos again, the effects of gravity and matter and this churning, spinning, dynamic dance. Is it not similar to this dynamic dance that we do within our love relationships and our intimate relationships? And is it not beautiful? For me, it is, to reflect on that kind of energy as an organizing, generative energy throughout the universe. Is it true? I don't know. It does inspire me, and it does ask me to sort of the question of identification. Can I identify with being a child? Don't put this in print, anybody. A child of the universe, as opposed to, or along with, a child of my mother and my father and all the other levels of identity. So that's what I was going for, really.
Yeah, and that's, I think others may want to comment on this, but that the universe seems perhaps so distant and cold and unrelated to our everyday existence, and yet we are so much a part of this. It may be vast and slightly overwhelming, but we are so much a part of the universe and the cosmos and its history and its dynamics. And I think that emotional connection is very, very important to give us perspective. Anyone else like to comment on that? Luke or Alvaro?
I have a very short story to tell about. David and I have had several ideas for collaborations, and one early one, we explored the poet and the scientist being at odds with one another in a sort of a theatrical production, and we realized that was fake. Like we kept agreeing on how we were approaching things, and David made the very astute distinction between my universe and the universe, and that comes into the poetry, and it also comes into this project. So we tried to be, the poet and the scientist, and we became storytellers.
Thank you, Luke. It's of course a joy to collaborate with you all. I think the line that sums it up is that the universe makes the mind makes the universe, and in the joining of this, somewhere revelation can begin. And that's not a fact, it's a hope, it's an aspiration for me personally, and just the willingness to share that.
That gives me chills on the video.
Yeah, it's a brilliant line.
Well, thank you for those comments and answering those questions. And it's so thought-provoking, so many things to think about. We can now open up the questions, I think, to our audience. So please do continue to write in your questions, and we'll be happy to answer those.
That's right. Don't be shy.
Okay. Well, we have a nice large number of questions that have come in. Welcome, everyone, and thank you very much for the questions that you've been sending us, and trying to. Four of us trying to organize these into sort of categories, and hopefully we'll get to as many as we can. And maybe just start with Luke. There was a question about the creation of these models, these scientific models. They're used in different colors. Can you say a little bit about how this modeling takes place?
It's important to realize that these are astrophysical models. So they're not special effects in the sense of making an artistic representation of something that we either can't see or that we need to see better. These are based on what we know and what we've observed in the universe. And we started with these because that's what they are, but also because they're so beautiful and so compelling, just visually. And but when you watch these simulations, they have no sound, and that's where Alvaro comes in.
And also, they're done on supercomputers, aren't they? You need a lot of processing power to move these galaxies around, almost of cosmic
yes, they are done on
supercomputers
supercomputers over sometimes weeks or even months of processing time. So yeah, they're quite spectacular just in terms of what it takes to bring them to us. And you see a 2 or 3 minute video that took several years to produce. It's pretty spectacular just as a project.
So as Luke said, these are silent movies, going back to the teens and the 1920s, when a soundtrack had to be added. And Alvaro, that's where you come in. You're adding a voice to these images. Can you say a little bit about your musical influences and maybe what you're drawing from?
So I grew up I'm from Spain. I grew up listening to lots of Spanish folk and classical music, flamenco, but also rock, heavy metal, and jazz. Um, then I started studying jazz very seriously, and also contemporary classical music. So 20 and 21st century music. And so if I had to summarize, I would say that some big names for me, and that I think their influence kind of shows up in these projects, are people like Xenakis, the Greek composer of contemporary music, who was one of the pioneers of using maths and architecture in music. And also John Coltrane, of course. And I think the spirit of Coltrane always permeates into these kind of epic type of melodies. So I think he was reaching for something. He was channeling some deep stuff. So I try to get to that kind of space for this, because the videos really help enhance that kind of intention. And so if I had to name three figures, would be in the classical realm: Xenakis, Coltrane for jazz and improvised music. And if we're talking about guitar stuff, I would say Derek Bailey, Alan Torchworth. Who else? This can be a very overwhelming list. But let's just leave it there. Derek Bailey, Alan Torchworth, John Coltrane, Yanis Xenakis. That's like my shrine.
Okay. Yeah, I don't know if David was listening with a list of poets going through his brain, so tick, tick, tick. Would you like to add, who would you like to sit and write poetry with when watching these images? Is there, who do you think would appreciate, and you can pick from any millennium.
Well, one of the things I love about Rumi, and he gets a lot of press, and I don't mean to overpress, but one of the things that I appreciate in Rumi's poetry is this bridging of the sensual and the what should we say, the eternal, the non-personal, the transcendent. And so I'm influenced by that. I also Whitman's sense of celebrating the common things with a kind of anthemic energy. I relate to those things in this particular project.
Yeah. Although I remember one of his poems, he actually walked out of the room where the astronomer was rambling on at the beginning.
I have a poem about that, actually. Whitman was like, he walked out of the room, and I can share that another time, but it was my answer to Whitman's thing, where we celebrate the gnarly questions and the equation on the blackboard. And let us all appreciate the hard work of the mathematics and the daring of astronomers to contemplate the unfathomable, which is what he couldn't do at that moment, because it's both and, the last image in our demo, you might have seen that, is at the very first clip that you played, is of Joshua Tree and the home galaxy and the Milky Way. So we are on Earth in our reality, contemplating this infinite space and infinite beauty. So anyway, trying to do that. We've got so many questions. I'm kind of got the little button here. Let me run to some of these.
Yeah,
great.
Yeah.
Let's see.
Thank you everyone so much for all your questions. They're all great. I just keep looking at my monitor. They keep coming, and they're all very deep and thought-provoking.
Wow, unless one let's see. What does it say? Simon, you're the host. You go ahead and do it.
Oh, be it. Okay. Unless one posits an organizing intelligence, can one see the process of cosmological evolution as an extended process of improvisation? Does the universe have a plan? I'm reading that. And the universe itself, rather than, we don't need to go to a higher level of planning, but is the universe itself predestined? What's it doing? Does it know what it's doing? Or are we just running simulation? Luke, how about that?
So
no pressure.
I actually don't think we could tell the difference. There may be a plan, but the universe is a eminently creative place. And the reason it's so creative is because it's not afraid to make mistakes. So the universe just tries things. I'm anthropomorphizing the universe here, obviously, but it tries over and over and over. But the universe has billions of years to keep trying. And that's where all of this amazing structure comes from. As a personal response to that, I'm not sure we could tell the difference. It sure looks sometimes like there is a plan, and yet a stochastic process is a process where seemingly random events create an ordered result, and that's what we're seeing here as well.
That's interesting, isn't it? Because there are only a few things that the universe is using. It's like, how many keys on a piano can you use to make music, and how many words can you make a poem? There's a set of basic rules. There's a set of basic elements, and there's gravity. And you with all of those very, very simple things, you can make humans, and you can make animals, and you can make stars and planets, and who knows what else. It's amazing that from simplicity, so much complexity can arise.
Yes, and when we were talking before about these astrophysical models that we use as the background, that's exactly what's happening. They're putting those things in as the input to the computer program that's producing the structure that we witness.
Mm-hmm.
I've got another question from Dr. Marsupial.
Luke. What developments in the field of astronomy? Okay, I can totally. So there are a couple of developments in the field of astronomy, and one we just witnessed. Computers are just getting more and more capable of doing these kinds of calculations so that we can make these simulations. And the cool thing about that is that we can compare those simulations to actual observations. And that's the other thing. The other advance is just the telescope technology, light detector technology, from gamma rays all the way through to radio waves, so that we can make these comparisons and in quite a lot of detail. So those are the advances. And then my favorite area is the formation of solar systems, but that's just me.
Okay, what does this say? I wonder what you've all had to sacrifice making these videos, and in having yourselves to adapt to drastic changes in the world like COVID. How has life, how has the work changed? I think that's a question for everybody.
Well, this whole process has been, for us, creating the effects of gravity. We started working live. We did a performance at Ithaca College. We did a workshop at Ithaca College. We did several here in the Hudson Valley. And then we had designs to do a series of performances and videotape it and be in a whole other place. Of course, we've had to go completely virtual. And our meetings and our development process has been deeply influenced by the fact that we can't be together, and the time factor is lengthened, and it's been hard. Though we've all learned how to do new things. Luke, were you editing video much before this?
No. It's a new skill.
Right. And Alvaro, have you performed in front of a green screen before this?
No.
Right.
But actually, even just before saying that, I'm just happy to be alive, to be honest.
Yeah, say more.
For those of you who don't know, I was sick with COVID. And it was awful. I got sick on the first week of March. And I'm still dealing with it, really. I mean, I'm kind of okay, but I'm dealing with a lot of fatigue and, some other symptoms. So yeah, I'm just happy to be here, to be honest.
Yeah.
Good question. I think we've all been really working super hard to keep momentum. That's really, I think, been the hard thing. Because between the space and the time, the energy it takes to send files back and forth. I just want to make a shout out to, behind the scenes, we have our wonderful producer, Bruce Berkey, who's helping us. We're all volunteering on this, right, to make this come through. And you don't see Bruce, but he's putting in a tremendous amount of energy to make sure that the communications are happening, that the videos get lined up, that the audio is working. And like all of us out there who are working in this now two-dimensional space, we've been forced to learn things and to learn how to cooperate and to collaborate in a whole other way. But you can't have that juicy energy of being in the room and the ideas spark and you read the body language and you have this intuitive space where you make choices. The feedback from the room, yeah.
One thing we found actually at the SETI Institute is that obviously all of our programming has gone online, and so we've all become experts, I suppose, in this medium very, very quickly. But it means that our audience has expanded globally. Whereas before we would have a seminar, with guests, people come into the auditorium, and we'd have Q&A and everything, and that's great, as you say, that's the personal interaction. But now, because everything's online, everything is a Zoom webinar. We have people from Australia, from Russia, from Azerbaijan, from Europe, from South America, from Chile, all tuning in. Some people are staying up the most ridiculous times to watch it, but it has become a global conversation. And that if there's a silver lining to this, maybe that is a silver lining.
I'm guessing Dr. Marsupial might be one of your friends. Let's see. This is a two-part question. You want to be the reader there, Simon?
Yeah, Neil deGrasse Tyson said during a public event that he wants artists to show him how the universe feels. And here's an example. His example was Van Gogh's A Starry Night painting. Which is not an accurate visual portrayal of the night sky, but is an impressionistic portrayal of the sky. Can you comment on this viewpoint? Do you want to help everyone feel the universe in different ways? Luke, do you want to go first as somebody who is already feeling the universe professionally?
Yeah, for sure. It needs to be tactile. I mean, I'm taking that completely literally. Like the ability to observe. The distinction between astronomy and the other branches of science is that it's purely observational. We can't bring these things into our laboratory yet, and so we have to observe them from vast distances. And so there is I think a lot of inspiration to feel. And I actually just noticed a question come up about sound, like sound in space. Is there sound in space, and could there have been sound in the beginning? And the answer is absolutely. There is sound in space. We're told there isn't, and there isn't in the ways that we are used to understanding sound. But there is a definition of the speed of sound in, for example, the clouds of gas that form a galaxy. Those atoms and molecules interact in the same physical ways that atoms and molecules interact in the atmosphere. You wouldn't be able to hear it if you were in space. But the cool thing is that the same, all of our senses sense physically here on Earth, and those same forces are everywhere in the universe.
Alvaro, you talked a lot about feeling when I don't know if you could say something about how your compositional process unfolds from just the feeling quality of the videos.
Sorry, you sound like you got quieter. I don't know if it's
I'm sorry, maybe it's my mic. Just wondering whether this question about feel, and you've talked, in other times about how you get a feel also from the simulations along with the explanations.
Yeah. I think I mentioned this before, but the idea of so I'm trying to get whoever is watching this to get both moved emotionally and intellectually. And so I have a bunch of tricks that I can use to poke that, but usually I don't have to use them in this project because the videos themselves and the poetry and all the facts, they are, again, they're just, this stuff is so awesome that I just immediately start, going with it. There's each video and each piece that we've done has a very specific wavelength. I don't want to get too new agey here because that's not my field, but they have an abstract identity to them that I can represent. I can access that with sound, And in my mind, each one has a very distinctive point of entrance to that kind of feeling. So all this to say that for instance, when you are reciting your poetry, I really look for your spaces, your inflections, your accents, your points of tension and release. So what I do is cushion that in different ways to enhance to coax the emotional content out of the poetry. And by doing that, the music becomes more emotional as well. So all this stuff becomes more organic, more tactile, like Luke was saying.
I think one of the
So I don't know
things,
if that answers your question, but
one thing that I really enjoy, I mean, a lot of space imagery gets these kind of like dreamy, like, kind
yeah,
of spaced out kind of musical things. And the poetry, I think what Alvaro is pointing to that I really love is the specificity. It's the moment by moment consideration of how our artistic choices and are serving this goal to enhance the feeling world and the
yes,
communicative power of the videos, the simulations, and the science behind it. The dedication is really very focused in a moment to moment. So it's not just laying down a bed of sound to dream with, but it's actually quite. For that 5-minute video you saw in episode 3, I think collectively we probably put in, I don't know, 100 hours more.
yeah. There's a lot of work there.
There's
Yeah.
like a lot of work in it, a lot you don't see. Here's another question that just came in, if I can be so bold. Let's see.
Okay, so what's this say? This is from Tails21ST, or 21st, I suppose. Please share about the video clips, the creation, the color, the shapes are brilliant. Did you create the simulations as well? Tell us a bit about the creation of the simulations, and that's probably to Luke.
Yes, so we did not create the simulations. We selected them from quite a few, actually. There are many, many such simulations. These were, excuse me, these were created by a team of scientists, computer scientists, and physicists, international team called the Illustrious Collaboration. You can look that up. And they have many other wonderful simulations, and we chose this one because it is dynamic, because it has a lot of the color, and the colors mean something. The colors translate to gas density, or the abundance of heavy chemical elements, or the location of dark matter. So there's a lot of depth to what you see and experience in these. They were originally created to understand the formation of galaxies.
Question from Andrew. I've always wanted to ask an astrophysicist this. If the universe is boundless, aren't we technically always in the center of it?
Yes.
Next question.
We definitely are. Right?
Yeah.
And one way to understand this, it's interesting that question came out that way, because often I get that question like, what? You mean, how can we possibly be in the center of the universe if it's infinite, or if it's possible that it's infinite? We don't know for sure whether it's infinite or not. And the answer is a little bit easier to understand if you remember that according to the Big Bang Theory, the leading scientific theory for the origin of the universe was once much, much smaller. And so you could imagine that everything was closer together at that time, and now it has expanded. And that expansion is evident in all directions. So anywhere you are in the universe, you view the universe as if you were in the center of the universe. So the good news is we're all the center of the universe.
Everyone and everything is the center. Yes. So we're all equal in that way.
Well, speaking of equality, we kind of felt like it'd be equal time to learn a little bit about what you do, Simon, and the SETI organization. I'm going to pop up the website real quick. Here's what it looks like, but maybe you can give us a little intro and then ask Bruce to bring your website up and you can walk it through a little bit.
Yeah, no, thank you very much. And again, thank you very much for asking me to join this project. It's been absolutely fascinating. The SETI Institute, which is located physically in Mountain View, California, in Silicon Valley, is a non-profit research institute with over 100 scientists that is dedicated to searching for life in the universe. And this is life in the universe of all its forms, everything from microbes to maybe bacteria floating in the high atmosphere of Venus, all the way up to advanced civilizations. And so we're going to have a quick look at the homepage here, which I invite you to go and explore our website. It will give you a lot more information on what we do. SETI itself stands for Search for Extraterrestrial Intelligence, and the Institute was founded back in 1984, 35 years ago, by a few names that you may have heard of. Carl Sagan, who's famous for the Cosmos series that people our age on the screen grew up with. Maybe not Alvaro, he may have watched it in repeat, but the rest of us were living through it. Jill Tarter, who is a radio astronomer from Cornell, just down the road from Ithaca College. And she was the inspiration for the character Ellie Arroway in the movie Contact, if anybody has seen that movie. And a third founder of the Institute was another radio astronomer called Frank Drake. And Frank Drake, back in the early 1960s, was one of the first astronomers to actually use radio telescopes to listen for signals from alien civilizations. Now, so far, nothing has been detected. There's been a few false alarms. But in the process of thinking about searching for an intelligent life, he jotted down an equation that is now known as the Drake equation, and we invite you to go onto our website, have a look at the Drake equation, and explore, because it lays out in various terms how you go about figuring out how many intelligent communicating civilizations there are in our Milky Way. Very, very difficult to think how you go about asking the question, and there we saw the Drake equation flash up. And the Institute, although it started off searching for intelligent signatures from intelligence, is what we call technosignatures. The work has expanded now to look for what are called biosignatures. That is, looking for life in the universe in all its forms. So we have scientists involved in the Mars rover missions. We have scientists who are involved in looking for extreme life on Earth, going to the Antarctic, going to the deserts of Chile, sending robots and machinery to the deepest trenches under the oceans. So there's a lot of thought about synthesizing all of these different ideas about what life is and where life can exist, to try and build up a picture of where we should be searching for life in the universe. As I say, take a look at the SETI site, take a look at the scientists and what they're doing. Some amazing work. Some is pushing the limits of what we understand to be life, and especially intelligence, communicating with different species on Earth, and how that would lead us to be able to communicate with alien civilizations. What's very interesting is one of our scientists, his name is Lawrence Doyle, is looking at communication with whales. We don't know what whales are saying. We can't speak whale, but we can tell that whales are having a conversation. And so in that sense, using actually a science called information theory, if we do detect a signal coming from space, you may not ever be able to work out what the signal is saying, but you can work out that it was generated by an intelligence. And so that's just one example of what the SETI Institute is doing. So please do come and join our cause, sign up for our newsletter, and all of this is available on our website. Take a peek there.
Thank you, Simon. Okay, there we have the split screen so everybody could see.
Yeah.
Beautiful. Hey, Bruce, I'm just going to say we should come back to our full share of the screen there. And I look forward to getting to that site myself. Simon, thanks so much.
It's been an absolute pleasure to join you for this episode. I'm looking forward to what's coming up next, and maybe that's a segue for you to let everyone know what we're looking forward to in the future.
Well, one thing we haven't really said so much about, you can go to our website at effectsofgravity.org. What we're trying to do is create a live performance. The idea is that we would bring these videos, this music, Luke's brilliant descriptions and my work to the stage, and then engage in healthy and fun conversations and workshops with folks at universities and science centers around the country. So we've been developing the piece over time, and our idea is to actually, once we can get through COVID, to start touring this project and to collaborate with different organizations to continue to develop it and open up this conversation, this meeting space between the arts and the sciences. So again, we have our website. Here's Luke has his own beautiful spot for sharing his thoughts on science and cosmology. And of course, Alvaro's just released a new album. I don't know why I'm being Papa David with this whole thing right now, but I've got the button, so I'm pushing it. Alvaro just released a brand new album yesterday. And mostly, there's my site, of course. We have another release, another Effects of Gravity live stream coming up on November 1st. So same bat time, same bat channel. Does anybody even know what I'm talking about?
Oh, yes.
Right, Boomer.
Yeah. That's sad.
Yeah. Anyway, thanks so much.
Thank you, everyone, for watching and your brilliant questions.
Yeah, really appreciate it.
Thank you.
And thank you, Simon. You did great.
Absolute pleasure. And I look forward to continuing to follow this journey.
Likewise.